Welcome to the presentation of O3AS service for Ozone Assessment, one of the thematic services being extended for a broader community within the EOSC Synergy project. EOSC Synergy project, with 8 participating European countries, is expanding the capacity and capabilities of the European Open Science Cloud, EOSC, by leveraging investments and existing experiences, know-how and resources of national, publicly funded digital infrastructures in a coherent way. Among expanding the capacity and building EOSC capabilities, the project also fosters EOSC services integration and promotes software and service quality. Thematic services in astrophysics, biomedicine, Earth observation, and environmental studies were selected to validate the service integration solutions. The expected impact is a measurable increase in the number of resources, services, and data repositories offered through the European Open Science Cloud. Ozone assessment is an important task for climate and environmental studies. After the discovery of the ozone hole in 1979, scientists all over the world got worried about the resulting dangers. Soon after, substances that destroy the ozone layer were prohibited with the adaptation of the Montreal Protocol that got ratified by the United Nations in 1986. Ever since then, reports have been compiled to assess ozone depletion. The last assessment report was published in 2018. The next one is due in 2022. For the compilation of the assessment reports, large amounts of climate model projections are analyzed to produce time series of ozone to detect trends and possible dates when the ozone gets back to the same level as in 1980. To establish a reliable analysis of the ozone return dates, climate scientists need a tool that will help to generate and reliably reproduce figures of high quality. The EOSC O3AS service shall provide such a tool. The current workflow of climate scientists includes a number of manual steps. The climate model data has to be downloaded and homogenized. Scientists then write custom scripts to process the data and produce figures of ozone time series. These figures are then presented to collaborators in various countries. However, this workflow has certain drawbacks. There are many manual steps. The custom code is not always publicly available or may not be well maintained. This leads to the fact that the plots are not easy to rebuild, especially with other input parameters like a range of years or latitudes. It may also induce inconsistency in the final results, and there is no way for non-specialists to assess the figures. O3AS is going to provide a user-friendly way of retrieving the data and getting high-quality plots for scientists and everyone interested in the ozone assessment. It also implies the best practices of software development, among which the code is open source, well-maintained and publicly accessible. It is implemented with the continuous integration and delivery pipeline based on Jenkins, which also includes automated code testing. The final artifacts are delivered in the form of Docker images. The code and the service are well documented. In order to provide convenient service, we first retrieve the original raw data from various ozone models and store them in the Large Data Storage Data Facility, LSDF. This data of tens of terabytes is reduced then to the parameters of interest by the means of the O3 scheme component. It runs regularly on the HPC system and stores reduced data back in LSDF. A user willing to assess ozone data comes first to our web application, O3 Web App, and configures the request. This request is passed to the O3 API component, which fetches the reduced data, selects and processes it according to the request, and returns a high-quality plot to the user. Scientists may get additional functionality from the service. First, they have to authenticate themselves via AGI check-in, then their requests are processed similarly, but in addition to a high-quality plot, they may get corresponding data points and perform interactive analysis in the web application. O3 Web and O3 API components are going to be deployed in a Kubernetes system at one of the EOSC providers. In the following, we show in action two available today parts of the service, O3 Scheme and O3 API. Original raw data comes in the form of netcdf files where relevant to ozone information depends on four parameters: latitude, altitude, longitude, and time. This produces a huge amount of individual values and terabytes of data, which is not possible to handle by simple machines as normal web servers. For the analysis of interest and to offer a service which the user can interact with on the order of seconds and not hours, O3 Scheme component averages the longitude information and uses integrated altitudes, therefore reducing the 4-dimensional problem to 2-dimensional and the size of data from terabytes to tens of megabytes. The scheming process is still a huge task in terms of computational resources. To make it feasible, O3 Scheme is automated and performed at a high-performance computer cluster. In order to run O3 Scheme, we have to configure the batch job script with the necessary parameters. For instance, the directories where the data will be taken from and where the output data will be stored, and also the YAML file to configure the data sources. Here is an example of this YAML file containing two data sources. The output directory has now no output reduced data. And once we run the script, submit the job, it creates the output data which we can now verify. First we look into the output of the job and see that indeed the data was processed. And then we find these two new directories. Now we go to the O3 API component. This component accepts user requests, performs data selection, final processing, and plotting. It is based on the Swagger tool, Connexion, and Flask Python packages. The API provides several methods like list available ozone models, get a particular model info, and of course produce a plot. As input parameters, the plot method currently accepts plot type, ozone models to process, range of years, latitude range, and it is possible to select particular months of a year. It returns the plot of interest or corresponding data points. Now we go to demonstrate how this component works and can be deployed at one of the EOSC providers. We begin from our main page, O3AS Data Kit edu. This has a link to the deployed service. Since the API container was removed for the purpose of this demo, we actually cannot reach the site now. In order to deploy the container, we go to the Infrastructure Manager and log in via AGI check-in. Here we can deploy various virtual infrastructures, including general Kubernetes cluster. In our case, there is already pre-deployed cluster at the CSK cloud. Then we go there to the Kubernetes dashboard, we log in there with the token, and we see that among the deployments there is actually nothing deployed at the moment. Then we can take the YAML file for our configuration from the GitHub. and deploy our infrastructure here. That takes about 20 seconds, and when this is deployed, well, this time is faster, and once this is deployed we can check that the service runs on the port. That's how it is configured, on port 30500, and once this is deployed we can then access the service. Here we can list the currently available models, and there is a multitude of them, and we can also perform plotting. Like we can take the month October and southern hemisphere region, the polar part. And here we can also see the reference level for 1980 and find out that it will come back at that region in about 50 years from now. The coming updates of the service include adding ability to produce more types of plots, for example so-called VMR3 zonal mean and TCO3 return plots. Also, the O3 web app component is being developed currently to provide a user-friendly web interface for easy plot customization and online analysis for authenticated users. In summary, O3AS is a service for everyone interested in ozone assessment. Researchers can in an easy way retrieve ozone model data, create publication-ready plots, and will be able to perform basic analysis. And here is the list of our public links. Stay tuned, and thanks for watching.